Hi everybody! So in today's video, we're going to be going through Unit 1, Lesson 4, which is all about connecting multiple representations of limits. So our learning targets for today are: I can create analytic, graphical, and numerical representations of limits, and I can identify key mathematical information presented in an analytic, graphical, and numerical representation of a limit and translate that information to a new representation. One of the things we are often asked to do on the AP test is make connections between a variety of representations. In today's notes, you're going to notice you've been given some information about a graph using limits. The first thing we're going to be doing is sketching a possible graph of this function based on the information that we have. Then we're going to be writing a verbal description, so using words to describe what these limits are telling us about this graph. So here are some strategies at least you can use to take limits and translate them to a graphical representation. The first thing you're going to want to do is determine which x values and which y values are going to be important to include on your graph. So because this first limit says the limit as x approaches 3 from the left, and the second limit says the limit as x approaches 3 from the right, I know that on the graph that I'm about to draw, having the x value of 3 is going to be really important here because all of my limits are talking about what happens around x being 3. Now, the second thing I should make a note of with my limits here are that the first limit has a y value that approaches infinity, and the second limit has a y value that approaches negative infinity. And again, these are the y values that we're approaching. So on the y-axis, I need to remember that positive infinity is way up here, and negative infinity is way down here. Now, if we imagine what's happening, as we approach 3 from the left, so from the left side of the graph, from this side, when I get closer to 3, my y values have to go up to infinity. And when I get closer to 3, my y values from the right have to go down to negative infinity. That tells me that on my graph, there's going to be a vertical asymptote at the 3. A vertical asymptote is a number that is not part of the domain of the function. So it means that our graph cannot touch that number. It forces, if you imagine it's like a wall, you can't cross the wall. So it forces your graph to go up or to go down because you cannot cross that line. Now, because from the left side I go towards positive infinity, it tells me my graph needs to go up on the left side of the asymptote, and from the right side, my graph goes to negative infinity. It tells me my graph needs to go down on the right side. Other than that information, the fact that the graph should go up on this side and down on this side, we can really kind of make the graph look however we want. So I could make this side go like this, and I could make this side go like this. It doesn't really matter. You could draw crazy shapes. You could make this graph go down and have a bunch of curves in it. It doesn't matter. You just have to make sure that these two limits are still correct as they correspond to this graph. Now, this should help you understand that the graph needs to have a vertical asymptote. So in words, here's what these limits are telling me. Whenever our y values approach infinity or negative infinity, and x is approaching a specific number like 3, it tells me the graph has a vertical asymptote at that number. So the description would be the graph of f of x has a vertical asymptote at x equals 3. One other piece of information that I want to note here is that we are going to be trying to draw the graph of a function. Now, a function must pass the vertical line test. So we should make a note here that the final picture should pass the vertical line test, which says that as long as you imagine drawing vertical lines and each line only crosses the graph one time, then you have the graph of a function. Since we want our graphs to be functions, each graph has to pass the vertical line test. All right, so let's go through this strategy again. First, we identified our important x values, then we identified our important y values, then we've tried to visualize what would be happening on the graph, and then we wrote some words to describe what we figured out. Let's use that strategy again in the next problem. So it says here the limit as x goes to infinity of f of x should be 1, and the limit as x goes to negative infinity of f of x should be 1. It seems like the important x values to include on our graph are infinity and negative infinity. So on our graph, we need to remember that on the x-axis, the infinity is here and the negative infinity is here. Right away, this lets me know that I'm not going to be worried about what's happening in the middle of the graph. I'm going to be thinking about what's happening on the edges, or in other words, the end behavior of the function. I can also identify the important y values to include on my graph. Since both of these limits are approaching 1, the important y value to include here is 1. Now, if we use our imagination to imagine what's happening, as x goes to infinity, so as you go this way, your y value approaches 1. So your graph must be getting flatter and approaching the line 1. As x goes to negative infinity, your y value should also be approaching 1. So on this edge of the graph, my y value should be approaching 1. When that happens, when your graph flattens out on the edges, we call that a horizontal asymptote. So I'm going to go ahead and sketch in my horizontal asymptote here. So as I go towards infinity, I need to approach 1. Now I could approach 1 by getting flatter from above the asymptote or below. It doesn't matter. I'm going to choose below because why not? And on the other side, I need to approach 1, and I could do that from above or below. It doesn't matter. I'm just going to get flatter towards the 1. Now in the middle, I can connect these two arrows however I want. I'm just going to make them kind of curve like this to connect the arrows. It doesn't really matter how you connect them. So because the only thing I need to do is satisfy these two limits, the middle of the graph doesn't really matter as long as it's a function. To make sure that it's a function, I can just imagine using the vertical line test, and no matter where I draw my vertical line, I'm going to pass that test. In words, how would I describe what's happening? I would say that the graph of f of x has a horizontal asymptote at y equals 1. Now, last but not least, let's apply the same strategy for the last example here. So again, it's good to start by identifying what the important x values are. The first important x value is 2, and the second important x value is also 2. So this is going to be a graph where I'm really focused on what's happening when x is near the number 2. When I draw my graph, I'm going to make sure that I include the number 2 on the x-axis. Then I'm going to pay attention to my important y values. So the first y value here is 4, and the second one is 5. Now, based on that information, negative 5. Based on that information, I'm going to make sure to include the number positive 4 and the number negative 5 on the graph. Now, it tells me here that as I approach 2 from the left, I should be getting closer to a y value of 4. So I'm going to find the point 2, 4, and I'm going to put an open circle there. I can always choose to fill that circle in later if I want to, but we need to remember that a limit does not mean we have a closed circle. It just means you're getting closer to a point on the graph. It could be open or closed. So here, From the left side, so from this side of the graph, I need to connect to this circle. Now from the right side of the graph, I should be getting closer to the number -5, which is down here. Again, I'm going to use an open circle, and the reason is because a limit does not tell me the function value. It doesn't mean that there's a closed circle there, it just means there is a point. It could be open or closed. Now that's from the right side of the graph, so from somewhere over here, I'm going to connect to this point, and there we go. Now that graph does not have an asymptote. You'll notice that we only have asymptotes when our y values are going to infinity or our x values are going to infinity. Here, nothing's going to infinity, so we're not talking about an asymptote. We're just talking about some sort of a jump in the graph. So we would say here, the graph of f of x has a jump at x equals 2. Now the next problem that we're going to do, and the last example in these notes, is a bit of a challenge question. So this one gives us a lot of limits to think about. And we want to sketch a function, so one graph that meets all of these qualifications. Now let's go through kind of the list here. The limit as x approaches 1 is 2. You'll notice this is a two-sided limit, so I need to approach the number 2 from both sides. As I approach infinity, my y value is -1 and negative infinity is 0. 5 from the left is infinity. 5 from the right is infinity. -2 from the right is negative infinity, and -2 from the left is infinity. What I'd like to do is apply the same strategy that we used for simpler problems to this more complex problem. So let's start by identifying our important x values. We know that we care about what's happening at x equals 1, 5, -2, infinity, and negative infinity. So 1, 5, -2, positive infinity, and negative infinity are the important x values to include on my graph. Now let's look at the y values. So 2, -1, 0, infinity, infinity, negative infinity, and infinity. So the number 2 on the y-axis is important, -1 on the y-axis is important, 0, infinity, and negative infinity. Now let's kind of go through these limits one at a time. What I'm going to be doing is drawing little pieces of the graph that satisfy each of these limits and then connecting each of these pieces at the end. So let's start with the first limit. As x approaches 1 from both sides, my y value should be getting closer to 2. So I'm going to find the point 1, 2 and put an open circle there. And I'm going to draw little connectors on both sides of that circle. It's just a little tiny piece of the graph. The reason I'm doing that is because if this is a two-sided limit, then I need to approach that point from both sides. Now, that doesn't have to be a closed circle, and the reason I'm not making it closed is because a limit does not necessarily tell me the function value, it just tells me what you're approaching. So it doesn't tell me there's a closed circle there. Now I'm going to do the limit as x approaches 5 from the left and 5 from the right. Since I'm approaching 5 from each side and getting infinity, it tells me there's going to be a vertical asymptote at 5. The only thing that there could be on the graph that would force my y values to go up to positive infinity and down to negative infinity would be an asymptote. So I would go ahead and draw a vertical asymptote here. Now from the left side, I want to go up. So I'm going to draw a little arrow pointing up on the left side of the asymptote. And from the right side, I want to go up. So I'm going to draw a little arrow pointing up on the right side as well. Next, the limit as x goes to infinity is -1. Now as x goes to infinity, tells me I'm looking at the end behavior of the graph. And since my y value is -1, it tells me there's a horizontal asymptote at -1 in this direction. So as I go to the right, I'm going to be flattening out towards the -1. So you'll notice I drew a little arrow as I go to the right at the -1. The limit as x approaches -2 from the right is -infinity, and -2 from the left is infinity. Again, the fact that the y values become infinite tells me that this is another vertical asymptote. So at the -2, I'm going to draw a vertical asymptote. Now on the right side of the -2, I'm going to point my arrow down towards -infinity. And on the left side, I'm going to point my arrow up towards +infinity. Last but not least, I'm looking as x goes to -infinity to be approaching 0. So as I go to the left, my y value should be getting closer to 0, which tells me there's another horizontal asymptote. I'm just going to draw a little arrow, and it doesn't matter whether it's above or below that line. Now my last step here is just going to be to connect all of these arrows. So I'm going to connect this arrow to the next one on the graph, which would be this one. If I go from left to right, I'm just imagining connecting them like that. The next one would be this one connected to the point that I drew here. And then the point connecting to this arrow that I drew here. And last but not least, this arrow connecting to this one, so it would look maybe something like that. All right, that was a toughie, but we can do this. We just have to use our strategy of identify your x's, identify your y's, look for major features like horizontal and vertical asymptotes, which we can determine by looking at the limits, draw little pieces of the graph, and then connect them at the end. Thank you guys so much for watching, and I look forward to seeing you soon.